Good morning, and we've returned to the Radisson JFK airport. And we're continuing with the application of the PDM SLS DLS. And specifically, we are using some of the 3x3 matrices, and we are forming a model 3-mesh circuits, and then we are making some voltage and current calculation. All right, we have just finished calculating. My name is Dolphy Gilpin once again. Dolphy Gilpin. And we have just finished calculating delta to be equals to what? 583. And also we just NI1 to be 26,088. Let's see if we got it right here. Yeah. N1 equal to 20 and delta equal to 583. And so that now we said now that I1 was equal now to NI1 over delta, and that's equal now to 26,880 over 583. And here we got now, we got 46.1063, 46.1063, and these 46484. These decimal point amperes are important in small circuit analysis when we are dealing with current in the nano region, in the pico region, in the micro region, and these will be very, very important. Right now we're dealing with some more macro elements here in amperes, 46 amperes, and it becomes relatively less effective, closer to be negligible. So delta is equal to that, and so the current is equal now to that amps. We find similarly NI2. NI2, by replacing now the source matrix here was 8, 5. That's right, those source matrix here was 8 now, 5, 3. Minus 570 and minus 304. So its delta was equal to that. And this came out to be 26,880. So now NI1, we replace this by the voltage now. We know that V1 was equal to 960, 0, 0, V2 and V3. All right? So we're going to replace this voltage now in the second column to find I2. So NI2 would be equal now to 8 minus 5 minus 3, 960, 0, 0, minus 3, 0, and 4. The determinant of that. So that's NI2 equals that. And therefore, I2 would be equal now to NI2 over delta equals to NI2 over 583. This is since the delta would remain constant right through to a calculation. Delta equals 583, that was calculated. All right, so let's try to find NI2. All right, if we take the simpler one to calculate it, because we're just going to calculate one column. We take the 960 column here, that will be equal to 960 NI2. Numerator value, 960 into minus 5, minus 3, 0, and 4. And let's see if we add these signs correctly before we proceed. 9570, minus 3, 0, and 4. All right. So this will be equal now to, no, the other one, the zeros with other matrices, 0 with another 2 by 2, 0 and 2, that will drop out because 0 multiplied by anything is 0. So the answer to Ni2 here would be 960 multiplied by minus 20, and 3 times 0 will be 0. So that would be equal to 960 multiplied by 20. We got a rough column here, 960 multiplied by 20 is same as 9,600 multiplied by 2. So that will be 2 now, 2 now, 2, 6 is 12, 2, 9, 18, 1, 19. 19,200. So that now, I2 is equal to 19,200 over 583. That's amperes. Once again, we could use our calculator to calculate that for I2. $19,200 divided by 583. That's equal to 32.933104631 amps. Once again, I said these small decimal place amperes would be a very intrinsic value if we are dealing with amperes in the region of pico amperes, nano amperes, microamperes. But since we're dealing with amperes here, we could probably run it off right there. But anyway, that's the answer, 32 amps. And I think this is positive. So that they assume a current for the circuit, which look like so. Let me drop in the circuit here. A sketch of the circuit that we were dealing with here would be so. With a total value here of 960, we call that say V1, and so that's some resistance there. Simple. And we had some values of resistance there. But that was the 3x3 mesh. This was mesh 1. And we were going clockwise with everything, so we say that this was now mesh 2. And this was mesh 3. This would be I3. This is the I2. So similar now we find I3. And we're going to make I3 as another session.